In this video, we will be continuing our lesson on geology. Basically, we will be tackling the lessons on the development of a theory and the theory of plate tectonics. So first, we have to know the term echo sounders. So echo sounders are used to measure how deep an ocean is. So in other words, it is used for seafloor mapping. For the echo formula, solving for speed, it's basically the formula S is equivalent to d over t, or in other words, speed is equivalent to distance over time. When solving for time, we still base our formula on the formula that we have for speed, but of course we edit it, we solve for t, and this is what we get. This is the formula for time. Time is equivalent to distance over speed. And for solving for distance, our formula is quite unique. Instead of writing S is equivalent to d over t, we add a times 2 beside distance. There is a reason for this, but I may not be able to explain it in this video. So it's basically, we're basically just going to morph that formula into t is equivalent to st over 2, and hence, this is our formula for distance. So an example problem. Provided that we have speed, which is equivalent to 1,500 meters per second, and our time is 12 seconds, we have to find the distance given the values above. So we have speed and time. Of course, we're going to find if we're going to find the distance, we'll be using this formula, which will basically end up to this, and we'll just substitute the values. So I do hope that you have your calculator with you, scientific or basic. I suggest that you use a scientific calculator. So for distance, it is equivalent to 1,500 times 12, then divided by 2, then you get 9,000 meters. So that's it. Let's move on to other terms that we have to know. In terms of the speed of sound in water, it's approximately 1,500 meters per second. Sound travels faster in water because sound is denser than air. And in terms of the sonar volume, it is 200 decibels or above, or higher, which makes it harmful to marine life since it's louder. 200 decibels is basically louder than usual gunshots, plane, the noise when you're nearby a plane with engines turned on, rock music, etc. Of course, the ears of fishes, whales, and nearby marine animals, they'll be able to hear the sonar volume, and it's going to rupture their ears. Maybe some marine life could die because of it. But still, sonar volume, it is very important in our use of echo sounders. So, there is another theory apart from the continental drift theory proposed by Mr. Alfred Wegener. We have the seafloor spreading theory, or hypothesis. Basically, it states that new oceanic crust forms along mid-ocean ridges, and old oceanic crust is located along coastlines. Lava builds up. Actually, this is basically everything for the seafloor spreading theory. This is a different theory. If lava builds up and cools down on the ridge, mountains are formed. If lava builds up, cools down on the ridge, and cracks, so please take note that if it cracks, mountain ranges are formed. But even so, even in that sense, mountain ranges are not that different compared to mountains, apart from the mountain ranges being a number of mountains than mountains being maybe 2 or 1 mountain only. So yeah, that's it. Let's move to the lesson of the theory of plate tectonics. So these plates or boundaries might be familiar to you. We'll just reiterate them. For divergent, this is the boundary where two plates move away from each other. Divergent plate can form valleys or submarine volcanoes. They form valleys when divergent plate, when earthquakes of divergent plate happen on land. And submarine volcanoes are formed uh, below the ocean, below bodies of water. So for transform, these are two plates that slide past each other. Transform plates can either create rivers or faults. For convergent plate, this is basically the boundary where it is the boundary where two plates move toward each other. So convergent plate, there is usually the occurrence of what we call subduction, whereas the denser plate goes down, and the denser plate goes down the buoyant plate. When we mean by buoyant, it's basically the opposite of dense. Let me illustrate. So, for instance, we have two plates, and when convergent happens, when the convergent based earthquake happens, this, for instance, this is the denser plate, and this is the buoyant plate. The denser plate would subduct or go down the buoyant plate. So yeah, that's it. Evidence for plate movement, as stated in the previous video, it's basically GPS, the Global Positioning System. For the types of convection, we have three. Basal drag, whereas the plate movement is similar to that of a conveyor belt, the one that we usually see in assembly lines in the workforce sector. As for number two, the second type of convection, it's known as the ridge push, whereas rising mantle material makes plates move away. As for slab pull, the last type of convection, this is where we see denser plates subducting. So yeah, that's it for this video, I suppose. Thank you for watching. I hope you've learned something.